Good afternoon, everybody. I hope I am audible. If I'm audible, could you please say it in the text box? Okay, thank you. So, good afternoon, everybody. So today onwards, we'll be having a new tutor. So I would like to introduce him. He's Mr. Sibin Sam, Development Engineer in Industrial Automation Solutions with Siemens. Sibin sir, I welcome you.
Thank you, Krishna.
Good afternoon, sir.
Good afternoon.
Okay, sir.
Am I audible?
Yes, sir, you are.
Okay, thank you.
So, guys, he will be a new tutor. Today onwards, he'll be handling classes. So, you may go with the class.
Okay, so I'm seeing only 40 participants. Is that the count? Or people will join in between?
Sir, actually, we have more than 40 people. I think they'll be joining in between. We may start because it's already 3:10.
Yeah. Okay. So in that case, I will share my screen. Let me know if you're able to see my screen.
Yes, sir.
Okay. So we will start with the session. Good afternoon, everyone. Myself, Sibin. I'm currently working with Siemens, Bangalore, and I'm an alumnus to College of Engineering, Trivandrum. So Shabana have given me this opportunity to present this particular session to you. So today's session is basically on the topic anomaly detection using machine learning. The agenda for this session, or how I structured this session, is we will go through some of the theory part of the anomaly detection, and I will provide a code walkthrough of one of the anomaly detection that is being used. So it is basically a Python code walkthrough, and apart from that, I am giving two assignments based on, one is based on the code which is currently I'm showing, and one is a different one. So this is what how I schedule the session. I hope everyone is comfortable with that. So we'll start with the session. As the first slide shows, we are going to look into the anomaly detection using machine learning. So first, we will take a look into what is an anomaly. Basically, on dictionary, when you see, you can see that if you search on the dictionary, it says something that deviates from the standard, normal, or expected. That's what called an anomaly. Basically, suppose we are having something, a set of blue pens. We bought a set of blue pens. Now, when we try to write with that, one of them is black. Then we can say that we expected blue, but that is a black we got. So that is a deviation from the normal, or that is a deviation from the expected. So we can consider that as an anomaly. Now, so in case of this anomaly, in order to find this anomaly, for earlier times, we will be using some particular algorithms based on the data we are getting. And that particular detection, in order to use to detect the anomaly, we were called that as anomaly detection. And as in the words, you can explain it as it's identification of the rare item, events, or observation which raise suspicion by differing significantly from the majority of data. So that is what an anomaly detection is called. say anomaly is something that is expected or that is deviates from the expected value. And in order to detect that, we will call that as anomaly detection. So how or what are the purpose of this anomaly detection? We can say translate that anomaly detection into some of the real life problems like banking fraud or some structural defect in some civil construction or some medical problem. Especially in the medical problems, you will get now we are using heavy computer applications to detect some of the MRIs or this CT scan or PET scans images. So we can say some if that scan actually has something that is away from the normal, then that's an anomaly. Then again, errors in the text. So when you are typing something on the email or in the using Microsoft Word, you can see that some of the words, if you have misspelled some of the words, you will get a red underline over that word. So that means the system is saying that there is an error in the text. And anomalies not only sometimes called as this outliers or nullities or noise deviations and expectations. So basically these terms based on the application we will be using. If we are having something based on the IT infrastructure, or if there is some data points and one particular data point is not linked or not at all correlated to the data points, we can call that data point as an outlier data point. Basically, we will be looking into this outliers today. And again, there is something called as noises. Noises, assuming when you working or when you tuning the radio, you will see if the frequency of the radio station is not matched with the receiving devices, then we will get a continuous interference over this radio communication. So that's an anomaly. So that's what called a noise over this radio communication. Then again, deviation and expectations. So why we need to use this anomaly detection in our day-to-day applications? The first thing, we can find out that there is some unusual network traffic from a particular device. Like if your system is affected by some viruses, or if you are actually Googling something, then the Google will say that there is a heavy traffic from your system to the Google server. So Google is finding that this is the not the standard expected behavior for the user to search something. Then what Google does is it will verify that the data traffic is created from you itself. So sometimes you will get some prompts that put a tick mark on the web page like I am not a robot. And apart from that, again, in order to give a more authenticity to the user, Google will say that please mark this images. If Google will give you some images, and we can say that we need to tick the correct images based on the suggestion from the Google. So that's for application where Google is using this anomaly detection for detecting the network traffic. If Google finds something unusual, then it will immediately revert it back to your system to ensure that you are actually using the system. So in the most of the cases, if you have some malware affected in your system, and that malware is actually creating some data traffic, then obviously this will be coming. Or otherwise, sometimes you are having multiple tabs open than the normal, then also that will come. So that's one of the applications of this anomaly detection. Then the second one is to uncover a sensor on a fritz. So basically, we have multiple sensors over an equipment. And if one sensor is not reading properly, then we can call that as an anomaly. And the next thing is to identify the data for cleaning. The data for cleaning means in this day-to-day life, we were hearing many thing about this data science as well as machine learning. So what it does is, for the machine learning, we need a perfect data to train our model. So in order to clean the data that we have received, clean the data means whatever we intended to choose to choose for that machine learning, we will be cleaning the data. So for that, anomaly detection is used. And the next point, with hundreds or thousands of items to watch, anomaly detection can help point out where an error is occurring. So that is correlated to the first point. You can say that there were multiple data points in your system, and you can correlate where the error is occurring from that particular data using this anomaly detection. Now, we had a data, we found the anomaly of that data. Now, what is the cause of that data? We can easily identify. Like a sensor, we'll go to the network traffic itself. So, if the system, if some of the person is having a heavy, unusual traffic to the network, then we can analyze the root cause of that network traffic issue. What is causing that heavy network traffic from your system? So, like I said, if your computer is affected by some malware that is using data over the data without the user knowing it, but the user know that he is not using this much amount of data, then the user can have an analysis of what is going on with the system. So it is easy to identify the cause with this anomaly detection, and we can actually get a quick tech support for that issue. Like we can install some antiviruses. Like if we found that a malware is causing this, then we can avoid that issues. So this anomaly detection helps in monitoring the chaos by detecting the outliers and informing the responsible parties to act. Now, the applications of this anomaly detection is being described over this slide. The first thing, as I mentioned earlier, we are having some data cleaning. Data cleaning means we have to clean the data that we have used. So that means we need to get a data that is beneficial for us. We are having millions of data points in our hands, but all of data might not be beneficial for us. So the data cleaning is intended to clean that data, and whatever the data that is being beneficial for us is being stored, and the rest of the data is being discarded. The second one is intrusion detection. Intrusion detection means it is basically for the network traffic again. So if I said if some system is or some server is having heavy traffic at some particular point of time, then we can say that there is an attack going to that server and the server might fail. So the users for that server can take particular corrective action to avoid that intrusion. Then comes the fraud detection. Fraud detection, especially for the banking industries as well as the credit cards and debit cards. If you see a person is having a credit card, and he's having a monthly usage of around 50,000 or 1 lakh. His spend pattern is actually common across all the months, but then one particular month he actually made some purchases that is crossing this his monthly limit, like 50,000 or 1 lakh. Suppose he purchased something worth 2 lakhs from his card. Then what the bank does is, the bank will not initiate that transaction at that particular point of time. He will get a consent from the user. Sorry, the bank will get the consent from the user, such that the user is actually perform that operation. Especially when you are using debit card or credit card, you might have seen this, and that is actually one of the application for this anomaly detection. Then again, the system health monitoring. System health monitoring, or you can say it as condition monitoring of the system. Suppose we are having some heavy motors, especially rather than motor, I will say pumps. So the pump is a combination of this motor as well as a rotor part. Then we can say in those motors, there will be multiple sensors incorporated to the motor as well as the pump section. Then we can get the data of those sensors from that particular device and monitor the condition of the device. Suppose at the beginning, from the end of the year, the voltage and current drawn by that particular pump is around common, but on one particular day it started to increase, and the next day again it started to increase. That means when you are looking into the previous data and says that this motor is not intended to draw this much voltage and current from that particular power supply, but the pump is now drawing that much, that means there is an anomaly going on with the pump. So the root cause analysis can be performed over that sensor data, and we can find out the fault from the pump. So this is just by identifying the fault, we can correct that fault, and we can maintain the pump for a longer period of life. So this is one of the application for the system health monitoring or the condition monitoring of the devices. Then event detection in sensor network. Basically, this application comes in the industrial 4.0 perspective. Every application, every devices is having automation incorporated, and that automation is being used. It's included with the help of this sensor devices as well as actuators. Now, what happens is there is a heavy traffic of data from this sensor network. So the sensor network, it might be either Profibus or Modbus or HART network, but from where that particular, if a sensor triggers something, from where that particular data is originated, we need to find out. So that's what the event detection in the sensor network means. And the next thing is the ecosystem disturbances. Ecosystem disturbance is similar to the last 2 points mentioned, that the system health monitoring as well as the event detection in the sensor network. So this is similar. If something is triggered from an unusual point, then we can say that it's an anomaly. So for the next slide, it shows the challenges of this anomaly detection. Now, it is tedious to build an anomaly detection system by hand because it requires domain knowledge and even more difficult to access the foresight. So what it means is, take the case of our pump itself. So in order to build an anomaly detection system for that pump, we need to find out from where the anomaly can originate. Okay, so that's we need to foresee where the actual errors can occur. So in the pumps, the major faulty points are the bearings. Then if say the pump is having some heavy vibration, so the vibration can need to be detected. So a person who is building that anomaly detection algorithm for the pump should have enough domain knowledge, as well as he need to foresee where those error can happen. So that's one of the problem if we build the anomaly detection system by hand. And for an ecosystem where the data changes over time, like fraud, this cannot be a good solution. So for the second point, we are again talking about the banking case. So when it comes to banking, say a person is actually having a credit card, is having a monthly transaction that is going over 50,000 or 1 lakh, but at some particular point, he purchased something around 1.5 lakhs. We can't say it is an anomaly because the person itself purchased that, but it doesn't belong to his monthly pattern. So that's not an anomaly. So that means that's why the data might be changing over the time. And when we build something, we build an algorithm using the intention that the person will spend only in the range between 50,000 to 1 lakh, it might not be a good solution. Then this is an example, actually building a wall to keep out people works until they find a way to go over or under or around it. So when a system fails, the builder need to go back and manually add further security methods. So just like building a wall, if the fraudsters or if some anomalies can go over this wall or dig a tunnel under through this wall, or if we go around the wall, then that means the builder or the person developing the anomaly detection algorithm need to create a solution for those three problems also. Then, as mentioned on the second point, manually building an anomaly detection is bad because it creates a system that cannot adapt. Adapt means, as I said with the example of the banking, the person had spent 1.5 lakh in particular month, but we can say that it is an anomaly. So the anomaly detection system need to be adaptive over the course of time. Now, we found the difficulties of building an anomaly detection system using some algorithms. So nowadays we are incorporating this machine learning technologies to this anomaly detection so that the anomaly detection system will work better, is adaptive on time, and handle large data sets. As discussed in the previous slide, we can say that this anomaly detection system using the machine learning can be adaptive over the time. Why? Because today there are machine learning models available that update itself even if we deployed in the field. In the field means even if we deployed in the application. So the machine learning, the data points from that will be updated over time or over the course of time so that it can be adapted. Then it work better. Work better means why? If we build a hard-coded algorithm for this anomaly detection and consider the case where the banking, or case of the banking, where the person spent 1.5 lakh. So that system will trigger an anomaly for that transaction, but it's not an anomaly. But when we come to machine learning, so it will analyze the past data and it will adapt itself so that the algorithm will work better and it handle their large data sets. So large data sets in the sense, it is based on the model we are going to create. So when creating this model, if we had a heavy amount of data, then the model will be performing better. So that's the base for every machine learning system. If the data set created for this model of machine learning is huge, then we will have a better model. Then again, in that data set, we need to have a clean data. Clean data means we should have the beneficial data. Okay. The data shouldn't have any anomalies. Now, we can also say that even with this qualities over the machine learning, there are certain conditions that the machine learning can work, but it is not limited to the condition that is being performed by a hard-coded algorithm. So what's the limitation? We need to apply machine learning to an anomaly detection that require good understanding of the problem, especially in the situation with the unstructured data. Okay, so the person who is developing the machine learning model should know about what is this anomaly detection model he needs to create from the data being given. So coming to the next point, suppose we are having some data and that data is structured. So that means the person who is creating the anomaly detection model is actually understands the problem space. Okay, he understands the problem space and the data, he know how to manipulate that data. Now, from that data or from the structured data, we can say that the anomalous data is easy because it breaks certain rules. Like an example, if it is given in the case of a sensor, which is reading till 100 degrees Fahrenheit, and the sensor is actually providing a data saying that now it is 300 degrees Fahrenheit. So that means a threshold has been broken because we have put a sensor to read only 100 degrees Fahrenheit from particular application. But the sensor is showing that no, from the sensor data, the sensor is getting 300 degrees Fahrenheit. So that's an anomaly. So that means either the threshold is being broken or the actual system is having some problem. Now, next, coming to the structured data again. See, as mentioned earlier, people have already an understanding of this problem space. That means the people who were working to create this model can interpret these settings based on the structured data. So that data is actually carrying some significance, or that data is actually having some meaning, and we can actually create some random trees so that we can look for some fraudulent data. Fraudulent data means we can look for some anomalies. Then coming to the next case for this dark data or the unstructured data. So such as two examples were given here. The images encoded as a sequence of pixels or language encoded as a sequence of character. So when you look into these two particular examples, we don't know what that data is meant to. Suppose the image is encoded as a sequence of pixel. Suppose the image is of cat, but it is encoded and it is now showing some blurry images. Okay, because of the encoding procedure. When we look into that, we can say that I can't identify. But when it is decoded, we can say that it is an image of the cat. So this is one of the problem with the unstructured data. Suppose the image of the cat is being shown as the image of cat itself, then that's a structured data, and we know it's an image of cat. But when it is encoded, the whole image become blurry, and we don't know what that image conveys. Okay, so that's an unstructured data. So that unstructured data are actually it didn't carry any interpretation or very little interpretations, and this hard-coded algorithms are being useless. So what we need to do is we will take that blurry image and we will put it into some machine learning algorithms like the convolution neural network. Then what it does is it will perform some operation on that particular blurred image, and it will try to rearrange some of the pixels or decode the pixels. Then what we see in that, we will get some structured data. Structured data means a decoding is happened, and from that blurred image, the actual image can be found out. Okay. So that is how we need to create a structure from some unstructured data. Then only we can give it to the machine learning model so that the whole model can be trained. So any unstructured data, what we'll do is we will do some structuring to that data, or we will add some dimensions to the data so that the whole data is presentable and a machine learning model can be created. Now the next thing is a large data set is necessary for creating this machine learning model. Then why? It is example with law. So like law, if there is no data to support the claim, then the claim cannot hold in the court. Similarly, for a machine learning model, in order to create a machine learning model, they require a huge amount of data. And in that data, if we had a 5 GB or 6 GB of data, from that data, again, we need to sort out what is beneficial for us. That means the valid data should be provided so that the model can be trained. So inferences can be made only when the prediction can be validated. That means if we have 5 or 6 GB of data and if we build a model, machine learning model from that particular data, what happens is the model might not be perfect because there are some anomalous amount of data. That data itself, there is anomalies present. Okay, that is not intended for our use. Anomaly is present in every data, but that is not intended to be used for our needs. But if we train with that whole data, then what happens is our machine learning model will not predict an actual value. Okay, so we need to clean the data again so that the predictions or the inferences made can be validated. So depending on the condition of the data, anomaly detection will occur on 3 different settings. So one is called the supervised settings, the second one is clean settings, and the third one is unsupervised settings. So we are having some data and we are going to build a machine learning algorithm or a model. So the first thing we'll be looking into the supervised data. So sorry, the supervised settings. In the supervised settings, what happens is we are having some data, and in that particular data, we are having labels as nominal as well as anomaly. So it's the label data we are giving in this supervised settings. So whenever a person is creating that data, he know what is anomaly and what is nominal. Okay. So what happens is all the anomalous points are known ahead of the time. That means, suppose if we have 100 data and we have chosen 80 data to train our model and we have 20 data points to validate. So in that 80 data points, there are some nominal data as well as anomalous data. And in the 20% of the split, then again we are having some nominal as well as anomalous data. So what we'll do is we will take that 80% to create our machine learning model for this anomaly detection, so that the model is created from that data and we will try to test that particular model with the 20% of the data that has been left. So that means if the machine learning model is accurately able to predict the nominal as well as anomalous data from that 20%, then we can say that our supervised settings training is actually successful. Okay. Now, based on this supervised settings, there are particular machine learning algorithm for this structured data. One is SVM for the support vector machines, then the k-nearest neighbors, Bayesian networks, and the distant trees. These are the common machine learning algorithms that is being used for this anomaly detection with the supervised structured data or the supervised learning. Now, the second one is clean settings. That means what happens is we are having some data and all the data points inside that data is assumed to be normal. Okay, it's nominal only, but it had some anomaly in it. We will say that we are having some 100 data points and we can say that all are normal, but there are some anomalies in that. So there is no particular relation between the nominal as well as anomalous data. So this is less of an ideal case, and it's very difficult to model from create a machine learning application using this plain setting, because we don't know what is anomaly and what is nominal. Okay. So what happens in this plain settings is the person who is creating that machine learning model make an assumption that this particular amount of data is anomalous and the next particular set of data is nominal. So it is up to the modeler or who is building the model for this machine learning. He determines whether what are the points of data or the data points is nominal as well as anomalous. The next thing is Unsupervised settings. So here it is contrary to the supervised settings. In the supervised settings, we are having some labels, that is the data is being labeled as nominal as well as anomalous. But in unsupervised settings, what happens is there is no label. We are having only a set of data. Now, what we need to do is there is no ground truth from which the outcome is expected. Okay, so there is no outcome or there is no ground truth, and the model, actually whatever the model we created from this particular data must show that the data is anomalous as well as nominal. As an example, again we'll take the example of the pump. The pump is actually taking around 11 kV supply voltage. Okay, so the 11 kV is the nominal data that is being used. So sometimes it will take 10.99 or 10.98, or sometimes it will take 11.0, 11.1 or 11.2 kVs. Okay, so the pump is running on this particular amount of data, but on some particular point of time, but the pump draws actually 11.8 kV of voltage. Okay, or suppose the pump draws only 10.2 kV of voltage. Then we need to identify that the difference. The 11.5 or the 11.8 is anomalous, as well as the 10.2 is also anomalous. Okay, so the model actually itself is created such that these data points can be shown as anomalous, and the nominal range that is being created as that is from 11.2 or in between 10.8, that is nominal. Okay, so what happens is it will create some clusters of the data or some groups of data using this unsupervised settings. As I said, the data between 10.8 and 11.2 is nominal, but any data apart from that is actually anomalous. So it will create some clusters like that, and the machine learning algorithm will show what is anomalous as well as what is nominal. So this is actually based on the approximate density estimation. So approximate density estimation means how many times that particular data point is being inferred for that model. Okay, so based on the density of the data points that is being present in the data, we will be creating some clusters of that data, and from that clusters we will identify whether it is nominal or anomalous. Now, some of the examples of this unstructured data algorithms are self-organizing maps, k-means, c-means, and exception maximization meta algorithm, adaptive resonance theory, and one-class support vector machine. Now we will come to the outlier detection. So outlier detection are of two types. One is univariate, and the second one is multivariate. So univariate means there is an extreme value. Okay, there is only one variable that is anomalous, and the rest of the data is actually clean. So that is called univariate. Only one data point is having anomaly, that is univariate. Then as the univariate, the multivariate means actually it's a combined unusual score on at least two variables. Suppose 2 or 3 data points being extreme and the rest are normal, then that from that data point or the 2 or 3 data points that is being extreme, we can say that the score is being calculated, and that is called the multivariate outlier. Okay. So in order to clearly understand that, we are having 3 variables x, y, z. So we can see that 3 axes were there, and it will create a 3D space. So whatever in that 3D space is actually the normal value. And apart from that, suppose there is one more axis is added. Okay, so which become a 4-dimensional space. Then that fourth dimension is actually an anomaly, and whatever the variables that is present in that fourth variable, that is an outlier, and that is a multivariate outlier. So what's the point we need to detect these outliers? This is a graph showing the speed versus distance of some particular event. So we need to actually calculate the average speed for this particular application. Then what happens is, if we consider these data points, actually only 4 data points were available, which is close to the 200, between 150 and 200%. So we will consider that this is an anomaly that is happened. Sometimes it might be due to some of the wrong calculation, or sometimes only at certain point of time 1 or 2 people have done this. Okay, but in most of the cases the range lies within 100. So in order to actually create a fitting for the data points, then we will say that we will not consider these values, so that our fitting will be much smoother, and we can go over this particular line. So this is why we need to identify the outliers. And again, coming to the case, these outliers cannot always be removed. Sometimes that outliers convey some meaning. Okay, so outliers always want a bad thing. Sometimes it will consider some meaning, but sometimes it won't consider. So if the outlier is not having any meaning, then you can actually remove that outlier. But if it is having some meaning, then actually you should keep it. So what are the methods used for this outlier detection is box plots, histograms, and scatter plots. So this is a straightforward method. If we had some data, we will plot the data, and we can see that some of the data is being clustered, okay, and some is being outside the cluster. So this is a straightforward method that is being used for detection of the outlier. Then again comes the next thing, dedicated outlier detection algorithms. So this means they process a large amount of data, and there are some pattern recognition going over this data, so that the outlier can be detected rather than this straightforward method. Okay, so the application of the fraud detection in the finance, and intrusion detection in network security. So that these two are the main application for this outlier detection, and it is not limited to that also. Okay, so I'm going a little bit fast because already it's 3:52. We will be using some of a beautiful library called Pyot for this outlier detection. So Python outlier detection library. So this is a Python toolkit. It's a simple API that is having over 20 outlier detection algorithms. So it had several advantages, like it's an open source, everyone can use it, and it will support neural network deep learning as well as outlier ensembles, and it is compatible with both Python 2 and 3. Okay, so we will go to some of the algorithms that is present in the Pyot library. The first one is the angle-based outlier detection for the ABOD. So what happens is we are having some data points, and what it does is between each point the relationship is being calculated based on the weighted cosine scores, and the outline scores is being actually calculated. So outline scores means suppose we are having 2 points, 2 data points in particular distance. Now, what it does is one data point is having some minimum, having a threshold value, and similarly, the other data point is also having some threshold value. Now, we are having a third data point that is away from this 2 data points we considered at first. what happens, that data point is also having a threshold. Now what we does is we will calculate the threshold or the distance between these two data points to the outside one data point we taken into account. So based on the threshold of that data point, some score is being generated by the outlier detection algorithms, and based on that score, actually that particular data point outside the two we considered is being calculated as nominal or anomalous. Okay. So the benefit of this ABOD is can be performed over this multidimensional data. Then there are two types of ABODs available. One is the fast ABOD as well as the original ABOD. So in the fast ABOD, what is used is the k nearest neighbor approach. So suppose if our data point is having 5 data points in a cluster close to it, then we will set some k values, and based on that, we will take the scores for this outlier detection. And the original ABOD, it will take all the data points. So it is actually more complex than the fast ABOD. Okay. Now the next point is the k nearest neighbor detector. So that is for any data point, the distance to the k nearest neighbor is viewed as the outlying score. And three KNN detectors were available. So one is the largest, use the distance of the kth neighbor as the outlier score. Then the mean use the average of all kth neighbor to the outlier score. Then the median uses the median of the distance to the k neighbor as the outlier score. So these are the three KNN detectors that is available with the PyOD library. Now there is this isolation forest. For the time being, I will provide this slide to you. So this has been explained, our isolation forest has been explained. So you can go through this. The second one is histogram based outlier detection. So histogram means, anyone know about histogram? Basically what it does is, we are having data, an array of data from 1 to 5. Okay, 1, 2, 3, 4, 5. An array of data. Similarly, a second array 2, 4, 2, 4, 1, 2, 5. So we have a set of array like that, that is ranging from 1 to 5. Now what we does is, in the histogram, what we does is, we consider all those array and we will group all the 1 to 1 as one bar chart. One column, all the 2's to the second column, all the 3's to third column, and similarly till 5 we will score that. And in that array, what happens is, the histogram will provide how many ones were present in the whole data, and similarly how many 2's were present, like that how many 5's were present for that whole data. So that is the histogram, if you simply explain the histogram like that. So this is for some unsupervised data. And local correlation integral, again I am skipping this part, I will feature bragging. So I will just give the names only. The PPT I will provide to you. And similarly, cluster-based local outlier factors. So these are some of the algorithms that is being incorporated with PyOD. So as an extra utilities, we can say that the PyOD can be used to generate data with some random, generate some random data with outliers. Now the Indian data can be generated by multivariate Gaussian distribution, and outliers can be generated from the uniform distribution. So we have a property, actually we are having a chance to provide our own values for the outlier fraction and the total number of samples. Then it can be used to create the data for the implementation of the machine learning model. Okay. So I will skip through the code. Can you see the Chrome window or the Colab window? Can anyone respond?
Yes, sir.
Okay. So I will share the slides with you since it is already 4. I will take only 10 more minutes. So the first thing, we need to install the Pyod library to this Colab. So for that, we will use the command !pip install Pyod. Now it will install the Pyod library. The second one, we will import the some of the libraries, that is NumPy, SciPy, and Matplotlib. Okay. Now what we will do is we will import the models ABOD and KNN from the Pyod library. So angle-based object detection and the KNN we will be using. Now, as I said in the previous slide, the last slide, the Pyod can be used to generate the data as well as outliers and inliners. Okay. So from the Pyods, we will import the functions generate data and get outliers and inliers. Okay. So we'll generate data that is X train and Y train using the generate data function. We'll be having 200 data points, and we are not having any validation data for that training data set. We are not validating that data because we will be visualizing that only. So we will say that the train only is true and the features is 2. Okay. So by features means it is an individual measurable property or a characteristics of a phenomenon. That's what called a feature. Like when I describe me, I am having a name as well as age. So that's a 2 features for me in order to describe. Okay. Similarly, for our data, we are having 2 different features and outlier fraction that is being set to 0.1. Okay. So outlier fraction means how likely, actually it's the score that tells how likely certain data point is an outlier or an anomaly. Okay, that's the outlier fraction. So from that X outliers and X inliers, we will be using this function for this outliers as well as inliers from this X train and Y train. Okay, so we will be getting what are the outliers and what are the inliers. Okay, similarly, we will take the number of inliers and number of the outliers. So I simply just printed this. If you see, there are 20 outliers in our 200 data points and 180 the rest 180 are the inliers. So that means from our 200 points, there are 20 anomalies and 180 nominal points. Okay, so if I print the shape of this X train, then you can say that it's a 200 data with 2 dimensions. Okay. So just to show the dimensions, I have used this ndim function. Xtrain.ndim will provide you the dimension of the data. So I just printed the data being created. You can see the Xtrain I have printed. So you can see it's a array of 2 elements like 5.3 and the 6.0, again 4.6, 3.9. So if you see through this data, you can see that there are the data lies between within 10 only or the 6. Okay. Then again, there are some negative data. So the negative data is also almost similar. You can say less than 5. So our data is in the range, we can say that from -6 to 6, or we can say that from -10 to 10. Okay. Similarly, I have printed this Y train also. Y train is a single set of array which is having 200 data points, which doesn't have any dimensions. Okay. So we will separate the 2 features and we will plot it. So we will take the feature 1, we will take the 0th column of this X train and add 1 dimension to that particular feature F1, and similarly we will take the 2nd column of the array of X train and we will add 1 dimension. So when I print this F1, you can say that the F1 is taken from the X train array. So if you can see 5.36 is the starting and 6.003 is the starting. And if I come back to F1, you can see the F1 will start from 5.36 because the first column is being used. And similarly, I think I didn't print the F2. Okay, I didn't print the F2, but I just printed the shape of the F2, that is 200, 1. Now, how that dimension is being added? Have you heard about the reshape function of this numpy? So what it does is the reshape, if we give -1, 1, then what it does is it will add a dimension to the particular data. Suppose we are having an array of data, 1, 2, 3, 4, 5, like that. And if we give that particular, suppose A is there, A dot reshape of -1, 1. That means the row element is being transferred as column elements, okay, and one column is being added. That's what the reshaping means. Like if I reshape this Y train, then what happens is every zeros and one will be incorporated into column. This is a row array, so it will become a column array. Okay. Now I will I will plot the F1 and F2 on a scatter plot, and if you can see from the data itself, we can see that this is some kind of inliers, and the rest we can say these data points are kind of outside from this particular group of points. So we can simply, by looking at this, we can say that this might be an anomaly and this might be some of the nominal ones. Okay, but in order to assure our assumption, we'll be using this Pyod library. So we have created a dictionary of the classifiers. This is from ABOD and KNN we are using. So we are having two dictionaries, two functions that we are going to check. One is based on the ABOD as well as KNN. So we have given an I, and we had given a classifier name and CLF in enumerate of classifier.items. So if you print classifier.items, this will be coming, the angle based, this two will be coming, and the first it will take the ABOD. So what this is, if the I is 0, then CF.fit of explain means, that means it is training the ABOD outlier detector. Okay, and it will have a score prediction, okay, based on the decision function of this outlier detector, ABOD outlier detector. So we will predict the values of this based on the X train. X train means the data we have given. So we are getting a Y prediction. Now we will calculate the error for that prediction, means Y print not equal to Y train. That means if some of these things, Y means we are having this label, nominal as well as anomalous data labeled, and if our predicted error is not equal to the Y train, then we can say that that's an error being happened, and we will sum all those errors like that, and we will print the errors. Okay. Now we can say that from the ABOD we got 6 errors, and from the KNN we got 4 errors. So based on the algorithms what you have chosen, there is a chance that the algorithm might be more effective over this particular data that we have used. So this is the cluster, or this is the same scatter plot we have given from 10 to -10. Okay, I just expanded it a little bit only. So as our assumption, this particular point of data is considered as the outliers, or inliers, or the true inliers, and the black data points, that is considered as the outliers. Okay. And similarly for the KNN, if you can see, the inliers are being calculated and the outliers are being represented as the black dots. Okay. So my point or my assignment for you guys is what is I want you to create a detector apart from this ABOD or the KNL from the payload library. Okay, you can choose any detectors that is being given to you in the slide, like feature bagging or lossy or something like that, whatever you like. So you can actually add some particular piece of code here to determine the inliers and outliers from the same data point we have used. So that's that's assignment 1. And for the assignment 2, I want you to, this is now a commented piece of code, so I won't show it to you. So how we detected this particular piece of plot, okay, how we actually draw some contours or how we actually colored this. So I want you to add comments to the code. What are the data being used? Okay, just add the comments only. Anyway, the code's been already given to you. So I just want to add the comments. That's the 2 assignments I'm going to give you. Okay. So I think this I will skip. I will give you these 2 assignments. Okay. So anyone having any questions so far? I know it's a bit fast, but I'm only getting this 1 hour. So I will provide you this PPT as well as this collab link so that you can work more on it. So if you found any troubles in any of this or if you have stuck anywhere, then you can actually take the help from me as well as the vendors for this course. Okay, so are we clear about the assignments that is being given to you? Hello.
Yes, sir.
Okay. So far so good, or it's over the good or the hedge. I know it might be a little bit over the hedge, but you can go through the site. It's self-explanatory only. Every session is like that till 4 only, right?
Yes, sir.
Okay, so I have crossed that limit. Sorry for that. Now, do you have any questions to ask?
So I hope nobody's having any doubts. Guys, if you're having any doubts, you may ask now.
Or later also, if they found when they go through the slides of the assignment, yeah, you can ask that if it's okay.
Okay, sir. So thank you so much, sir. And also I thank each and everybody who joined the session. Thank you.
So thank you all. I will post the assignments by today or tomorrow, and let's see for the next session.